In this example, I need to sketch 5 pi in standard position, and then I need to find the 6 trigonometric functions for this angle. As my angle does not have a degree symbol on it, I know it's in radians. And remember, standard position means the vertex is at the origin, the initial side is along the positive x-axis, my angle is positive, so I'm going to rotate in a counterclockwise direction. However, this angle is bigger than one rotation of 2 pi. So I need to use coterminal angles, which when you're in radians differ by 2 pi. So you take the given angle of 5 pi, subtract one revolution of 2 pi, 5 minus 2 is 3 pi. Still bigger than one rotation. So again, subtract 2 pi. 3 pi minus 2 pi is 1 pi. That lies between 0 and 2 pi. So now I can sketch my angle. It is 2 full rotations and then another pi radians. So first rotation, second rotation, and then another pi radians. So there is my angle sketched in standard position. Now to find the 6 trig functions for this angle, I need any point along the negative x-axis. It doesn't matter which one I pick. I'm going to pick the easiest one where x is -1 and y is 0. But the x value could be any negative x value. The y value will always be 0. So for this point, I know x is -1, y is 0, and I need to find r. Remember, r squared equals x squared plus y squared using the Pythagorean Theorem. So r squared is x squared is -1 all squared plus y squared is 0 squared. So I'm going to get -1 all squared is 1 plus 0 squared is 0. So I know r squared equals 1 plus 0 is 1. Remember, r is always positive, so it's the positive square root of 1, which equals 1. So now I know the values of x, y, and r for this point. I can find all 6 trig values for this angle. So I'm going to start with finding the sine of 5 pi. The sine function defined in terms of x, y, and r is y over r. Y is 0, r is 1, so it's 0 divided by 1, which equals 0. Now to find the reciprocal function, the cosecant of 5 pi. It's the reciprocal of the sine function, so it's just going to be r divided by y. So that's 1 divided by 0. So the cosecant is going to be undefined at 5 pi. Next, let's find the cosine of 5 pi. That is x over r. X is -1. R was 1. -1 over 1 is -1. The reciprocal of the cosine function is the secant function, so the secant of 5 pi is going to equal r over x, which is 1 divided by -1, which is -1. And lastly, let's find the tangent of 5 pi. In terms of x, y, and r, that's y over x. Y is 0, x is -1. 0 divided by -1 is 0. And lastly, the reciprocal of the tangent function is the cotangent function. So the cotangent of 5 pi is the reciprocal of this ratio, so it's going to be x over y. X is -1, y is 0, so the cotangent function is also undefined. One last thing I want to point out is every coterminal angle of 5 pi will have the same values for all 6 trig functions. So whether I'm trying to find the trig functions for 5 pi or 3 pi or pi or 7 pi or -pi or any odd multiple of pi, the trig function's values will be identical.